We need to know what nothing is because we're going to encapsulate it to there. We're going to put something outside of nothing, if that's absolutely possible, right? And here's comes from an article, okay? No, I'm sorry. This, I think, it's from a YouTube video. This is their this was their icon there, and it says there's a wall, there's a universe, and it stops at some kind of wall, and then nothing continues. And that's so weird. How can it, you would say, how can matter and space stop there? And what, nothing continues? I thought space was nothing. Here you have space, and it's both the black stuff on the left and the black stuff that's in with the matter on the right. That's space. We call it nothing, vacuum, void, whatever you want to, zero, zip, whatever word you want to use there. You want to use the word X, the letter X, do that, no problem. But the issue is they have this notion that after matter, nothing continues, whatever nothing is. Okay, and again, the issue here is whether they're going to ever define the word nothing, and that's the main problem, that in hundreds of years, no one has ever defined what nothing is, what space is, what vacuum is. They never defined it. They talk about how filled it is. Is it full? Is it infinite? But they never talk about what it is, and they don't give us a definition. No one has defined it in years. And here you have a bunch of philosophers, a list of them, just an impromptu list, people who attempted to define the word nothing or void or vacuum or space, whatever you want to call it. They're all synonyms in physics, and none of these people ever figured it out. And I've just put a small list there, but there are tons of other people who tried. No, we don't have a definition of nothing. Okay? And they just tell us that it doesn't exist. It's not that we can't define it. It's that it doesn't exist, so why take the trouble, right? I guess that's their reasoning. And here you have one of these so-called philosophers. They're not even philosophers. They don't know what philosophy is because no one defined philosophy. That's another problem. But this fellow, Martin Heidegger, and he said the most fundamental issue of philosophy, why is there something rather than nothing? Okay? And I thought there was nothing as well. We have something and nothing. We call that nothing space. So yeah, we have, if you call it have, again, that have has to be with quotations, but there's, the universe is composed of two parts. One is the something and the other one is the nothing. That's how simple it is, our universe. And he says there is something because there is literally no such thing as nothing. In a way, he's right. There is no such thing as nothing, but he's talking about something else. He's saying that everything in the universe is so filled, filled to the brim, that there is no room, no possibility of there being a nothing because everything is filled, which was the notion that Parmenides had, that everything is filled. It's not that there is no nothing, really, it's that everything is filled, and so there's no room for nothing. That's more or less their notion. And we're saying that his statement there is something else. We're saying that, yeah, in a way, he's right. There's no such thing as nothing because nothing is not a thing. In fact, that's what no thing means, nothing. Not a thing, yeah? But that's a wrong definition, again, an irrational definition. Nothing is not a thing. You can't say that nothing is no thing. That's an irrational definition. It's an antonym. What they put there in antonyms are irrational definitions. They're circular definitions, more so when they never define the word thing. Nobody has an idea what a thing is, and then they say, oh, by the way, nothing is the opposite. It's no thing. So we have no definition for thing or for nothing today. And that's where the problem starts. Definitions, they never define these words. Here's an analysis by one person who looked at it in great detail. Says nothing is explained as not anything. Yeah, see, there's the problem. That's an irrational definition. Nothing is not anything. Okay, that's an irrational definition because not anything means all you're saying is nothing is not a thing, which is correct, But what's a thing? And they say, well, a thing is a not nothing. So we keep going around in circles. They don't have the word thing defined. They want to define nothing. And again, having no single thing. Can we ever have nothing? Now they're talking about having nothing after defining it improperly or irrationally. Can we ever have nothing? It is impossible to have nothing. Okay? And they talk about have. You can never truly have nothing. Even if we believe we have nothing, that is something. And no, if you have nothing, you don't have something. Not yet. Okay? Because to say that you have nothing is not something. And this is where the problem is. It gets very tricky because they never define these terms. And here you see how they get confused because they start putting things that have nothing to do with nothing, with the word nothing. And they say, we have a reality, thoughts, we have knowledge, we can never have nothing. Why? Because we have all these abstractions, right? We call thoughts, reality, knowledge, intelligence, all these concepts. And then they compare that with what you see in the green part, where they talk about things related more to physics or traditionally to physics. They really don't have anything to do with physics, but it's traditionally in physics. It says, what we think of as empty space in our universe is not actually nothing. It contains energy, radiation, and particles that flit in and out of existence. Obviously, they're talking about the virtual particles. And so they're saying, look, you're comparing thoughts and knowledge on the one hand against particles, radiation, and energy on the other. Okay, and they're comparing apples and oranges here. And one thing has nothing to do with the other. And so that's why they say you cannot have nothing because there's always thought, there's always knowledge, there's always all these concepts rolling around, and that's something. That's the notion these people have. They're comparing absolute things that are irreconcilable. You cannot match them or in any way. It says attempting to picture nothingness is impossible for the human mind. I don't know why they have a problem in picturing. It's that black stuff in the night sky. That's what nothing is. It's called space. And so I'm not sure why they can't picture nothingness at least as a dark background. No, not infinite because it's not a thing and things can only be finite. So space is not an infinite thing, okay, as all these people think, okay. Space is something else, and we're going to get to that. We do not know what actual nothing is. So that after saying all that, they define it, and then they say, oh, but we don't know what it is. No kidding. And they talk about the existence of nothing. And again, this is where the problem is. These people have for hundreds of years said the same thing, even from the days of Parmenides. What's an object? Well, that's what you can see or touch. And they immediately say that whether it exists or not. They talk about existence of a thing. Whether when the word exists should not even enter the discussion yet. But they start putting whether a thing exists or not. And that's the same thing they do with nothing. They say, well, nothing. What is it? Well, it's the opposite of a thing. Okay, and the problem is it doesn't exist. What do you mean it doesn't exist? What do you mean by that? What do you mean it doesn't exist? Does it exist or doesn't it exist? What are we saying? What is the person trying to say when he says nothing doesn't exist or it does exist or whichever? You cannot talk about existence of a concept. And that's what these people are saying. They're saying there's nothing and it exists or doesn't exist. You can't even use the word exist in terms of nothing because it's a concept. You can only use the word exist in regards to things. You can say a thing exists, right? So if God is a concept, God cannot exist by definition. You don't have to believe or non-believe or doubt. It's got nothing to do with belief. It's got to do with the definitions. If exist means an object that has location, then if God wants to exist, he's got to be an object to begin with. Then he's got to have location. There's got to be a distance between his chest and mine. There's got to be a separation there. Okay? Otherwise, God doesn't exist by definition. And it's the proponent who has to say, let us assume that God exists. Then he can continue. But what did he say? He says, God is an object and God has location. That's what he said when he says, let us assume that God exists. That's the way it works in science. Okay, and so we had couple people here came with questions. Here, the first one says, if concepts have reality but not an evidence as far as physics is concerned, how do you square that? And again, these people get tripped in the language because reality is a synonym of exist. That's where the problem is. And there you see the definitions. Reality is equal to existence. They're synonyms. If you look at reality, something that exists independently of ideas concerning it. Exist, to have actual being. What is actual? Existing in fact, in act or fact, real. And being, the fact of existence. So all these words are synonyms. They never define any of these four words. And then you can see why it's a circular argument that all these people have. They use, so this fellow says, if concepts have a reality. No, concepts don't have a reality because reality means exist. All you said, concepts exist. That's what you just said. For that, we have to define the word exist, reality, actuality, being, whatever you want to call it. Okay, and there you have it at the bottom. Exist, physical presence. Physical means object. It has to have shape. Okay, if you have a shape, you have an object. Okay, and presence means location. So an object that has location is one that exists. Okay, and it has to be an object. Can't be a concept. So you cannot say that a concept has reality or that concepts exist. It's an irrational statement. Okay? And that's the problem. The problem is no one ever defined the word exist in the last 10,000 years. Okay? And then continues related to space, whether space exists, or what it is. What is space? What is this nothingness? And the same fellow said, okay, so space as rationally defined is an endless, large, empty, what? Expanse. What the hell is an expanse? I mean, these people use these words. They find them in Wikipedia or whatever. Don't just put words in there, find out what the word means. You can't just say it's empty expanse. And what's an expanse? Well, you look it up. An expanse is what? An uninterrupted space. So we're saying that space is a space, is an uninterrupted space. That's all you said so far. And again, people will get tripped because they don't look up these words and they have never been defined. So you shouldn't even look them up in the dictionary. You have to sit back with a beer in your hand and start visualizing. What do you say? How do you define these words? What do they really mean before we use them? Okay. And another fellow says space is zero-dimensional, as three-dimensional what? Continuum. What's a continuum? Again, they put these words in there like, oh, you understood, right? It's a continuum. And you look it up, it continues extent. What's an extent? Well, something that extended. That's what it is. So you haven't said anything. By saying space is an extent or a continuum or an expanse, you haven't said anything. And this is the problem. We don't have rational definitions in physics. Okay, we had to come in there and define these words. This is the issue. Definitions. Very important. People say, oh, Bill, you're doing semantics. No, you need to do semantics in physics if you're going to, or in science in general, because you're going to convey a thought. You're going to convey a theory. Your key words had better be understood. And the only way you're going to get them to be understood if you define them crisply, rigorously. And so that's what we do here. We define them rigorously. Here it goes. Okay. These are the foundations of physics. You cannot do physics without these 7 words at least. There's some more, but those are the main ones. You can see space is among the most important ones. You need to define what an object is, what a thing is. You need to define what space is. And space and object, space and thing, nothing and something are exact antonyms. One is that which has shape, and the other one is that which doesn't have shape. That's what space is. Space does not have shape. That's why you cannot draw space. You cannot make a picture of space. Okay? And then you have all these other words. Distance, you need to have that word distance, separation between objects. Location, the set of distances. Exist, what does exist? Well, again, it's the physical presence, an object that has location. Motion, 2 or more locations of an object. And concept, a word that invokes or embodies 2 objects. You need to define the word object before you define the word concept. And again, concepts are very different than objects. Objects have shape, concepts don't have shape, among other things, right? That's not the definition, but you get the idea. You need to define these words. You can't do physics without them. And no one has ever done that. They start talking about physical interpretation. Oh, what is gravity? Forget about gravity. You don't even know what a thing is. And they think a thing is that which you can see or touch. You can't see or touch gravity, the mediator of gravity. So they say, well, there's nothing there. Well, no, because that's not the definition of object, of a thing. Thing is not that which you can see or touch. Thing is that which has shape. Some things you can touch, some things you can't. And some things you can see and some things you can't. Especially, the table on the other side of the universe. Hopefully a table is an object, but you can't see it or touch it. And so you can't say that see, touch is the definition of a thing, of the word object. Okay, so what do all these people do? Well, general relativity proposes Big Bang. There was an explosion sometime 14 billion years ago, rounding off the numbers, right? Because they keep changing these numbers back and forth, 13.7, 13.8, 14, same thing. We had a beginning to the universe, and they never go to frame number 1. Okay, they go to frame number 2 and they start there. They said there was a singularity. God put it there, who knows what, and then it exploded or expanded or whatever. Expansion of space, they call it. Okay, it looks more or less like this. I think all of you have seen it somewhere, here and there. You have this explosion, right? And the matter just got pushed away by space, because space is actually exploding there. It's pushing everything outwards, okay, like a hand grenade. Think of hand grenade, nuclear bomb, whatever you want to think of that as. That's what it is. It's an explosion. A lot of people don't like the word explosion, but that's what it is. Matter and space are hurled outwards from ground zero. Okay, very simple concept. That's what these people believe in. And it looks more or less like this. Okay, this is the dark energy pushing everything outwards. Okay, you can see it there, coming out. Okay, so that's the notion that they have for how the universe started. It's a creationist theory. They don't like that word creationist because it's attached to religion. But then the question is, what is all that pushing up against? I mean, is space is in that stuff that's moving outwards, is space and matter's there. What is it pushing out against? I think it's a valid question. And they say it's an unscientific question. Partly because they can't answer it, obviously. But they say it's an unscientific question, partly because, they can't prove what's out there. They can't run an experiment. It's just what they call philosophy. And then Stephen Hawking came up with this one-liner, says it's like asking what's north of the North Pole. Yeah, what's north of the North Pole is a star. Okay, that's what north of the North Pole. Okay, but he's got these geodesics ending at the North Pole and says, what's north of the North Pole? He says, oh, you're there already. There's nothing there. Well, north of the North Pole, you got to go upwards. You got to go in a different direction. No geodesics necessary. Okay, so this is the notion they have. It's called the balloon analogy. Okay, you have dark matter and gravity, and dark energy and anti-gravity. Okay, one's pushing out, the other one's trying to hold everything in, and then you have this explosion. This is the balloon expanding, okay? It's pushing outwards, okay? And so, this is the notion they have, that we live in some kind of ball, and it looks more or less like this when it's at maximum. I guess this is the present right now. You can see everything is on the edge of the ball, okay? So I think a valid question here is, if we're all on the surface of that ball, right? All you can do is look with your telescope. You can look sideways. You can look along the surface of that balloon. But what's the white stuff? I mean, I don't see any white stuff in the night sky. I see stars. So no matter how I look, it's always stars out there. So what are we staring at? I think I'm staring towards the white stuff there, and I'm seeing stars. And people say, no, it's the balloon that we're on the surface. So I should point my telescope along the surface and should be seeing galaxies and stars and so on. But what if I point in the direction of the white part? What would I see? And so in order for these people to more or less make sense, you would have to have at least two levels. Okay, here's one level where some stars and galaxies and so on are further up ahead than us. We're the blue there, right? So we would point our telescope forward along towards the white, but we would see the black stuff there, the galaxies and stars that are further than us from ground zero. Okay, and if you point it in the direction of the Big Bang, right, when it happened, then you should see something like that with another group of stars and galaxies which are a different level than us. So you would have one in front and one in the back. That's the only way I can conceptualize it, because when you look out at the night sky, you see stars. But then the question is, what would the person, or assuming there are people, right, in another planet, right, and the people who are in the farthest reaches from ground zero, what would they see? Would they see white stuff? Is that what they see? They look in our direction, they see us. Okay, they see stars and galaxies. What do they see if they look in the direction of the white? What would they see? Do they see white? What do they see? They can't see stars because it's a balloon that's exploding. Okay, so you see the problem, and and so we have a problem because to see stars and galaxies the way they explain it, we would have to look at along the surface of the balloon, but then what's on my right side? What's on the white side? What should I see there? I don't see white. I see stars and galaxies. And so you say, well, they're up ahead, they're forward, they're in front of us because they exploded before we did. Okay, fine, let's concede that. What does the person who's at the edge of that ball, the biggest ball, right, the farthest from ground zero, what do they see? Do they see white or green or whatever? This is the question. So it's misconceived. Whatever these people are talking about is completely misconceived. Okay, so how do I explain that some stuff is in front of us? Because they have an explanation for that as well. They say, well, here you have an explanation of why some stars and galaxies are in front of us, because they exploded before us, or their explosion, they went faster than we did. I have no idea. The balloon is expanding and we have all these different levels. And so this fellow explains it like this. Says, when we launch a rocket, as the rocket goes away from us, it consumes less fuel because the force of gravity acting on it decreases continuously until it becomes zero at infinity. Okay, so that means, you're getting farther away from gravity and more closer to non-gravity. Okay, that's more or less the notion of this dark energy thingy that's pushing everything apart. And the force on the object is decreasing as they keep moving forward. This means the retardation of the object is decreasing and the net acceleration is increasing in the opposite direction, the direction away from us. Objects at the edge of the universe, are accelerating because they are farther from us, and though we are accelerating as well, they are accelerating at a magnitude larger than us in the same direction. Okay? So what this fellow is saying, right, and I guess a lot of these so-called scientists agree with him, now because this guy is, again, a physicist, one of these mathematicians. And what happens is, there's some people that are in front of us, some galaxies, stars, whatever, they're apparently further in front of us from ground zero, from Big Bang. And so what happens? When we look, they're getting farther and farther away faster. Why? Because they have less gravity tugging them towards Big Bang. We have more matter closer to Big Bang. They have less matter, and so they're flying away faster because they have less pulling on them. That's the notion. Whatever gravity is, right? All we know is that it's mass and gravity, and we don't know what gravity is. We don't know what mass is, right? Because they have 10 different definitions for mass. So again, definitions, okay? Okay, so here's an analysis of that. It says the observable universe, because they don't always talk about, the universe itself. They say the observable universe because they look at observations, experiments, what they can prove, so they say, And so they say, look, it's the observable universe. That's all what we can see, and that depends on light. So it contains only the light that has had time to reach us. It's getting bigger and bigger. It's finite. Okay, so it's a finite ball, right? We cannot see further than light speed allows us to. Okay, so it's only what the light allows us to see, right? But we know there's more universe beyond that limit. Space is infinite and full of galaxies, stars, and gases, okay? So either space is infinite or space is finite. So they talk about the observable universe, meaning the observable space, you could say, right? Space ball. We can see that because it's within the speed of light. But anything beyond that, they just dismiss as infinite. They say, oh, it's infinite, and that way they just put it out of your reach. They say, look, don't ask any more questions because it's infinite. Okay, we're done. We fixed the problem, right? Infinite universe is hard to imagine. No kidding. It's beyond imagination. Infinitely many parallel universes exist. Okay, so they have all these infinitely many parallel universes. They have a lot of all these universes everywhere, all these big bangs throughout. And I guess one big bang must be coming in our direction, because if they're expanding and we're expanding, at some point, I guess we're going to crash against them, right? And I like the final one. So there's an exact copy of you in each universe. Okay, so hopefully you're still in this universe, because all these people are flying out in other universes. These people call themselves scientists, physicists, mathematical physicists, theorists, theoretical physicists. They have all these names. They are complete incompetent people. They have no ability to think, let alone to do anything else. Okay, so this is what it looks like, okay, more or less. All these parallel universes, you live in one of them. I hope you can find yourself, but you don't have to find yourself because you live in all of them. There's a copy of you in each one, okay? So sometimes they look like this, okay? You have the multiverse, okay? Again, you can put them in parallel universes, or you can put in multiverses. There are other universes out there, and you can see as they expand, they're going to be encroaching on each other. They're going to squash some of these other universes out of existence, I guess, or merge with them. Who knows? So they have these notions. The question is, what's the black stuff? Because remember, space is within each one of those balls. Each one of those balls contains stars, galaxies, gases, etc., asteroids, planets, moons, etc., right? And space. Because between the Earth and the moon, we have what we call space, that black stuff out there. And so what's the black stuff that separates these universes if the black stuff is already contained within each universe? Remember that Big Bang created space, according to general relativity. Okay? So we have a universe that contains space and matter. Space is expanding. So what's the black stuff against which this space is pushing? We have to identify that black stuff and that container, whatever that black stuff is. And they never define that. They just illustrate it. Ridiculous illustration that you see there. But this is what they illustrate, and they say, look, there it is. Every universe is separate from other universes. So we don't know where the black stuff is. That's what they need to identify. What is that? And one fellow talks about infinite bubbles, another so-called scientist, right? And says expansion of the universe after the Big Bang led to the formation of bubbles. We have bubbles in the structure of space. Space has bubbles. It's the bubble space. And bubble wrap, maybe, Each bubble will stop expanding together with the rest of space and form its own universe with its own laws and physical constants. Where do they get these ideas, these idiotic ideas? In this scenario, space is infinite. How can it be infinite? You just told me it's finite. That each one is a bubble. A bubble is a finite entity. But here's how they explain it. And each bubble for itself is also infinite because a single infinity can contain an infinite number of infinities. So now they're not talking about the space that is the bubble itself. They're talking about what the bubble contains. They say it contains a lot of stuff, and it's infinite stuff, infinite number of things. So they're talking about two different things. These people don't even have the ability to rationalize simple things like that. And so it's very hard to talk to them, to exchange ideas with them, because they have these irrational notions where they have a bubble that's expanding. They're talking about a bubble. A bubble is finite, and they say, look, the bubble is space, right? Because it's pushing all this matter outwards. And they say this bubble, it's finite, but it's infinite. What do you mean it's infinite? Because it's got infinite things inside it. Which is not the question. The question is the space infinite itself? And they say, no, it ain't. It's finite. And so, they have this duality. Their spaces are all finite and infinite. And so when you talk about what's outside of space, they say, well, it's infinite. And they say in that way, they cut you off. They say you can't ask that question because the universe is everything, space and matter. And since space is infinite, the universe is infinite, it's everything. You cannot ask what's outside the universe. But then they say it's also finite because it's expanding, but it's infinite because it contains infinite things inside the bubble. So it's like, these people have no ability to rationalize simple things. That's what it comes down to. And just in case, we throw in the string part of it, the string theory version, and it says string or membrane theory. The rippling membranes beyond the worlds in the 11th dimension. Oh my God, how many beers? For the 11th dimension are completely different universes, and when the ripples collide, a new universe is formed. They call this science or philosophy. Who knows what they call this? It says all the gravity we experience in our universe actually enters this universe from another universe. Okay, that's why we have gravity, right? Because if we have gravity from another universe, then we have a problem because remember what dark energy is, which is pushing everything outwards? Well, I guess it's being pulled, that dark energy is being pulled by another universe that is coming our way or whatever, right? That is nearby. In another dimension, they have to put it outside your reach. So they put it in the 4th, 5th, 11th, 26th dimension. They have all these dimensions out there so that they put it out of your reach because you say, oh, dimensions, what are those? Oh, that's beyond my comprehension. And don't worry, it's beyond their comprehension as well, okay? They don't understand it either. Which explains why gravity here appears so weak compared to the other fundamental forces. Okay, I hope you understood all that. Okay, so here's an experiment for you. You like experiments? Let me give you an experiment that you can do. I'm not sure you're going to be successful, getting an answer from, but I want you to get the idea. Okay, so here it is. Here you have a chamber, right? And it's got all these particles in it. Yeah, this is a vacuum chamber before it is it's sucked out. In other words, before the vacuum is sucked out of it. Okay. And so what we're going to do, we're going to move the chamber from A to B. Okay. So there it is. Okay. We're going to have this, let's put this one here. See here, we move it. Okay. So moving the chamber. Okay. Stickman moving the chamber over. And so we're going to move it over there. So it was over here on this side, on the left side. Okay. And he's going to push the chamber over. Okay. Now, as you can see, when he moves it, the particles have moved. Okay. So you can see that he moved all the particles, because, particles have no way of escaping the chamber. You can put whatever particle you want in there. You can say, look, it's, atoms. You can say it's dust. You can say it's water. You can say whatever it is. It doesn't matter. Whatever. If you move the chamber, it's going to move together, all the particles together with it. Okay. And now let's look at a different scenario. Here we have another scenario. We have a vacuum chamber. We vacuumed all the particles out of it. There's no particle. Let's assume we achieve perfect vacuum. Okay. So we have empty space there. Okay. Complete empty space. We removed all the particles. We have a super duper pump that pulled everything out. God's pump. Okay. I wish I had one of those when I was at AMD. So we pull all the particles out. There's nothing there. Now the stickman's going to move it over. Okay. He's going to move it over to the side there. Okay. And the question for you, the $1 million question, is whether we moved space with it. Did we move empty space with that, just like we did with the particles? I mean, is space a thing that you can move, that you can put in a vacuum chamber and say, okay, I'm going to move space, a portion of space or whatever? Or did space filter right through the vacuum chamber? Did you encapsulate space? Can you encapsulate space? That's the $1 million question. And you don't even need to do the experiment. You can just think of it this way. Everything in the universe moves. The earth moves. constantly. We move with respect to Jupiter. We roll around the sun, right? So we're twirling around. We're already moving. So you don't have to move the chamber. It's already moving with respect to everything in the universe. Okay, so the chamber is moving already when the Earth rotates, okay, around the sun. And so the question is, if you have completely empty space, is the space being trapped there, being carried together with a vacuum chamber? Or does it seep right through it? Does it filter through it? And are we getting new space as we go along? What is it you have trapped in there? Okay. And the question is there anything that can encapsulate space? Thought, the 10th dimension, the 11th dimension. What encapsulates space? If space is nothing, space is that which has no shape, there's no way you can encapsulate it. So this notion that they have that there was a Big Bang where space was part of this Big Bang, half of the equation, you have matter and space, right? Space is pushing everything outwards. Whatever turned into matter was floating in there somehow, and space is pushing everything outwards, right? So it's a valid question. What is it pushing up against? If space is nothing, right? Then you have to tell me what is encapsulating nothing. Not the matter. Forget about that. That's easy. The question is, what is encapsulating space? What's encapsulating nothing? Void, vacuum. And because they're treating it as a physical object that is expanding. Okay? So the question is, what's on the outside of it? And obviously they can't answer that question. That's why they say, well, it's an unscientific question and blah, blah, blah. They go off on tangents. They can never answer that question. And so the Big Bang theory is irrational. There was no moment of creation where there was an expansion of space against whatever was out there. Nothing, like if space were a different word than nothing. And so space was expanding. What was expanding against? And otherwise, Big Bang is garbage. It's nonsense, poppycock. You're talking about an expansion of space. You're talking about expansion of nothing. Only things can expand. You can say a balloon expands. We all understand that. You inflate it and the balloon inflates. You have a surface that is expanding. We all understand that. But to say that space is a balloon that's pushing all the galaxies outwards, well, then you got to tell me what's on the outside of it. It's absolutely required. Otherwise, you are conceptually wrong, right? Or irrational, really, not wrong. It's always irrational. Wrong is an opinion. Irrational is defined. Okay, you have an irrational assumption, and your theory is garbage, poppycock. It's known as general relativity.